Hello, everyone. Let's talk about mobile web today. What do I mean by this term? Not just browsing the internet using our mobile devices, but actually creating some kind of mobile experience using web technologies. Basically, building any form of mobile apps using JavaScript. On my next slide, I'll introduce myself. Meanwhile, please give me a favor to think about an answer to one simple question. Just imagine your product manager, boss, customer comes to you and says, we need an app, mobile app, and you're a front-end web developer. Which option would you go for? Searching for an answer on this question on our today's agenda. My name is Maxim Salnikov. I came to you from Oslo, Norway, where I work for the company called ForgeRock. I love build UIs for the future. And why do I talk about this topic at all? Because I'm really interested both in web technologies and mobile development. I run local meetups dedicated to mobile development and web development, as well as to conferences. My Twitter is webmaxru. It might be useful for you because I'll post the link to my slides, to this slide deck, immediately after the session. You remember the question, right? First, let's understand why it's ever raised. We all are here mobile phone users, right? What about some global numbers? They are pretty impressive. First, in 2014, the number of users on mobile devices bypassed number of users of desktops. It was quite serious milestone. Next, starting from October 2016, just 1 year ago, mobile devices started to consume more traffic than desktops. This is also really, really impressive. What about absolute numbers? This is statistics on smartphone users. So we moved from general mobile devices to smartphones because smartphones are our target for today's session. This year, it's well over 2 billion. Actually, it's 1/3 of our planet's population. Let's have a look at the evolution of web-based technologies for mobile apps creation. Who remembers the name of this technology? Yes, please. Yes, it's WAP protocol with its own language, WML. But we skipped this era. It was really first try to expose the web to mobile. And we are jumping straight to smartphones age when it's become possible to render more or less real-life applications inside our mobile browsers. So this will be our first milestone. Then, thanks to media query, we could implement responsive web designs. Next, we could create nice hybrid mobile applications. After some time, we could go native. In this sense, I mean quite special kind of native, which is JavaScript-compiled-to-native, and some unknown yet hero. Let's call some names from these milestones. jQuery, mobile version, Bootstrap, well-known UI framework, which is mobile first, starting from version 3 for the responsive web design. For hybrid, I believe Ionic framework is the most well-known one. For native, most likely you heard these two names, at least, NativeScript and React Native. You see that according to my color coding, there are two totally different eras, right? Before this, these red items, hardware, our mobile hardware, was low performant. And JavaScript inside mobile browsers was painfully slow. In addition, there was no chance for us to get hardware of our devices. Because of this and some other issues, Mark Zuckerberg in 2012 said this famous quote, and mobile web was not in a good shape in this year. I found this really great visualization timeline showing us this gap between two eras really clearly. So on this side, we have very early versions of PhoneGap, responsive web design, and first attempts to implement mobile UIs frameworks based on web technologies. Starting from here, mobile browsers got much better. They started to support more and more HTML5 features and even some device APIs like geolocation, camera access, and some other stuff. And here is this gap. So we can say that on the left-hand side, it's mobile web 1.0, and what we have now is mobile web 2.0, right? Or second edition, or just mobile web done in a proper way. Let's return to implementation. How can we use all these exciting possibilities? We'll have 4 interesting approaches for today's session. Ionic, NativeScript, React Native, and some unknown hero. Who could imagine what will it be? Hint, remember some meetups I organized in Norway? Exactly. Yes, you are right. This will be progressive web application. It would be a big mistake for me to ignore this approach to build mobile web experience. So despite it's not a framework, we'll definitely have a look at this today. Of course, there are many more frameworks, right? Why do we take these 3 plus PWA? Because they are, first, open source. You can use it without any worrying about licensing, even React Native at the moment. And they are widely adopted by developers. So let's have a closer look on each of these 4 approaches via some experiences. First, developer experience. We are all developers, right? So it's important for us. Next, user experience. We build our applications for customers, right? Plus, of course, we are users ourselves. And just a bit of business experience. Before we dive deep into comparison, let's give a brief technical intros to each technology, each approach. We start with Ionic, classics of hybrid mobile web development. So basically, this is a website, right? HTML, JavaScript, CSS, maybe some graphical assets running within native container. Its slogan is one code base running everywhere. And this is not just marketing. We'll check what's so unique with Ionic a bit later. Let's list some features. For this and all next feature list, I will go only for those points that are really distinct, this approach from each other. Ionic, main one, really single code base, okay, almost single code base for web version plus native stuff version. Web application in a web view. This is really a weak side of Ionic, right? But this is how technology works in general, hybrid one. We have web application running in what we call web view on native platforms. It's powered by Angular. But for next generation, it will be based on Stencil, a really new framework from the same team, which converts your JavaScript code to web components. So soon, it will be framework agnostic. And it uses Cordova to actually create the container and access native APIs. Our next hero, NativeScript, totally different approach. As a result, we have truly native application without need to use WebView. How it's possible? I'll give you all these technical details a bit later, but first let's list features. It's recommended to use Angular framework, but if for some reasons it's not an option for you, you can always use vanilla JavaScript. Application is shipped with virtual JavaScript machine, or to be more specific, one of these JavaScript virtual machines, because they are different for different platforms. Thanks to this fact, we have really direct access to all native APIs. Here is a very rough explanation of how this magic works. Okay, our JavaScript code interpreted and executed inside JavaScript virtual machine. I remind you that we ship this machine together with our application. It's V8 JavaScript engine for Android and WebKit JavaScript core for iOS and Windows Phone. All calls to and from native APIs go through NativeScript runtime, which includes metadata, predefined set of all available APIs for each platform, type conversion engine, because we use JavaScript objects on one side and we have to convert it to native object on the other side, plus call dispatcher, which actually performs these calls. This scheme guarantees that we can access any function inside our device, right? So technically, on NativeScript side, we have like JavaScript objects performing like proxies to native objects. But in this scheme, we have to know exactly which function are we going to call for each specific platform, right? Which could not be very useful for us if we create multi-platform application, right? Luckily, NativeScript includes one more component, which is platform-agnostic abstraction layer called NativeScript modules. It translates the code from platform-specific to generic one, right? So we hide this complexity connected with multi-platform support. Basically, we hide the specific platform itself from our code. We just call some native for our code functions. Next, React Native. Result is really close to what NativeScript does. 100% truly native application, but approach is different again, totally different. Its slogan, learn once, write anywhere. Why? It doesn't promise us single code base for all the platforms like NativeScript tries to do, and we'll check why in just 30 seconds. Main features. We have so-called bridge between our JavaScript code and all native UI layers. It's inspired by React, but of course we can't say that this is React.js. Thanks to its architecture, we can do two really amazing things. First, we can have React Native application as a part of our native one. And this is the way how it works, for example, for your mobile Facebook application, for your mobile Instagram, and Airbnb, and a lot of other really native mobile apps. Plus, we can include modules written in native language. So basically in Objective-C, Swift, Java, Kotlin, real native code. So we can plug it into our JavaScript application. Let's have a quick look on how it works. We run our JavaScript code in a separate thread. We use JavaScript interpreter for this. Another thread is responsible for application UI. So it works directly with native platforms, platform UI, and specific platform APIs. Between these two threads, we have what we call asynchronous bridge, which makes this communication possible. And thanks to this architecture, we can do really great things for us, for developers. So we can just run the same code in a totally different environment. For example, we can run it in Chrome, not in real device, not in emulation, but via WebSockets, we can redirect this asynchronous bridge to our Chrome, which is great for debugging, for hot reloading, for great developer experience. Progressive web apps, after all. What they based on? Simple. They just adopt best parts from two universes, mobile native applications and web. We are free to choose to go for some framework or go without the framework at all. And the core idea, we just use modern browser APIs and just follow some best practices. So this is not a framework. This is not a, I don't know, platform. Not even methodology. This is just the way we create modern web applications. Cornerstone of progressive web applications is Service Worker API. The application, outer world, and Service Worker code in between intercepting requests from our app and serving its own responses, with going to network or without. We decide this. Both app and Service Worker live in browser, but live totally different lives in totally different contexts, though. What could we implement using Service Worker API? We can get some functionality of our application available offline, like starting up in general, like serving some previously cached data, and even fancier stuff like replaying network requests done when user was offline automatically after they get to online. We can improve online performance, actually following the same idea by serving some previously cached data from the cache. Network magic is not the only features Service Worker API is responsible for. Also, it receives push events from messaging services, and it displays notification, even when our web application is not running at all, so when there is no tab with our application. Also, we can provide communication between all our open tabs and Service Worker itself, and a lot of other things. It's quite an extensive API, and it's living specification. So more and more features are appearing. Good. What's current support status? In 3 previous approaches, we were more or less safe because we had compiled application and we could almost make sure that all features we asking about will exist in this native app. But here in PWA, we run our application in browser. So we depend on APIs exposed by this specific browser, a specific version of browser. I have good and bad news here, and this blank slide symbolizes this. Bad news first. It's not in production for all major browsers yet. Good news, these APIs are under active development, if not in production. In short, Chrome and Blink engine-based browsers like Opera and Samsung Internet, as well as Firefox, are in the game for at least a couple of years. So they are quite good in supporting all the latest and greatest features of Service Worker API and other APIs related to progressive web apps. Starting from this August, Service Worker is under development for the WebKit. So it means soon, I hope, we'll have it in Safari browser, which will be absolutely game changer for progressive web app support on mobile devices. Because now, absence of this API in Apple mobile devices is one of main showstoppers for this idea in general. Microsoft Edge, behind the flag, starting from this autumn again for developer editions. It's actually good for us, for developers, to have some time to test how our progressive web applications will behave in Edge before this API shipped publicly, which will happen hopefully next spring. Well, now we know how everything works. Let's check what do these approaches expose for us, for developers. Installation, setting up, scaffolding are really smooth and nice for all these frameworks, and for PWA if you go for some frameworks. So nothing really interesting to compare here. Each one has its own CLI equipped with all you need to scaffold application, to preview, to emulate the app, to share it, to deploy it. So it works really well. Tooling is very good. This is the bottom line. What about coding experience? What do we use to actually write these applications? So let's have this kind of table. Ionic pretty opinionated, I'd say. Angular plus TypeScript plus HTML. Why it's HTML? Because basically, Ionic has its own markup, which is technically XML. You can use regular HTML text, of course, there. So you can easily recognize what's going on here, even if you see the code from Ionic for the first time. Looks like we have some header, right? We have the button and some text over and under the button. If we run this code, what we will see? Next slide, please. Yes. The button is looking like this. Output is different for different platforms. This is the nature of Ionic. Using CSS, it tries to mimic native UI for iOS, for Android, and recently they added Windows Phone support. NativeScript. Angular is optional, but if you go for Angular, it's really good idea to go for TypeScript, of course. Otherwise, you can use regular JavaScript. For UI layer, you will have to use XML with its own set of components. Why? Because there is no document object model anymore. We are not working with HTML. The same piece of functionality written in NativeScript. Action bar, which is kind of header, button, and some texts. And result is following. Obviously, it differs from what we seen in Ionic, because these are native headers and native buttons for iOS and Android. Good. React Native. It's inspired by React, so formally we can say that we use this. It means that we go for ES6, great, relatively new standard of JavaScript, and JS6 for templates. So if you work with React.js, the code will be really, really familiar to you. So classics of React apps. Believe me or not, but we didn't have button component in React Native until November 2016. So we got simple button just a year ago. Of course, there were some other ways to provide this active area for our screens, much more lower level. Finally, we are really happy to have this component result. And by the way, the color we specify on this code for the button has different meaning for different platforms. For Android, it's background color. For iOS, it's text color. And you can ask me, where is the header from previous samples, right? And this is a good moment for me to tell about this mantra of React Native. Learn once, write everywhere, instead of single code base. As you remember, idea of NativeScript, our previous one, is to hide platform differences, right? Behind its own set of APIs. So we put this action bar, and we don't care, is it iOS or Android, it will render some native component for us. But these platforms, iOS, Android, and Windows, are fundamentally different. And the meaning of this quite simple component, which is just a header action bar on the top, is totally different. It plays different roles on these platforms. What React Native does, it embraces these differences instead of hiding this. So in common, in general, we have to go for two different components for two different platforms. So here, sample for iOS, we are using Navigator iOS component here. For Android, we can go for Toolbar Android, again, native component. No worries. There is a really nice way, or nice ways, to separate these differences in our code base. So we can have different components for different platforms, both on files level, just following some file name naming conventions, or we can have this possibility right in our code. So basically, it's not a big issue. So this example, previous one, demonstrates fundamentally different approach between NativeScript and React Native. But real life is, as always, a bit more complex than this ideal world, right? For example, in this action bar, there are still some differences between iOS and Android, even in NativeScript approach. Why? Because I mentioned it for a short time, it plays different roles for these platforms. For example, for iOS, back button we have on this action bar is explicitly used for navigation, so you can't override this action. On Android, on the other hand, we cannot specify text for this button. We always have to go for icon. On the other hand, there are some cross-platform implementations for React Native. So for this particular example, I can recommend you to go for React Native navigation component. OK, our next hero, progressive web apps. Super simple. Any framework. If you go frameworkless, use any language that could be transpiled to JavaScript and old good HTML. That was about coding with some focus on UI. What about hardware? Because the whole point to have what we call mobile application is not just mimic website inside our mobile device, but provide more interesting features connected with device hardware itself. Ionic. We go for Ionic Native. Nice set of plugins, and actually these are Cordova plugins wrapped into some containers that's convenient to consume inside Angular applications. So they all expose observables or promises. There are really many plugins available. Let's have a look at Camera. So we install it using Ionic CLI and npm. And here is sample of code. So if you have seen Angular from 2 to 5 code, it looks really familiar for you. Import, this is a regular ES6 import. Then dependency injection, we use in constructor as a parameter. And then using getPicture method of camera, we just get the image object after this promise solved. NativeScript. We have direct access to all native APIs, remember, right? Via NativeScript modules. Also, you can take any native plugin from CocoaPods, which is a package manager for iOS. And of course, it's already equipped with hundreds of own built-in and driven by community plugins. And the list is really exciting. You can find pretty much everything you can even imagine to use for your mobile phone. Let's look again at how Camera will work. We install it. The code is pretty much the same. We still use Angular in NativeScript. Again, import. Again, promise. And we got the picture. That's it. React Native. First, some hardware APIs are exposed as a part of framework itself. Also, you remember that we can write really native code to plug into our web application. So if you're brave and if you know Objective-C, Swift, Java, Kotlin, whatever, you can go for this. Plus community-driven components. Again, a lot of really nice ones for all possible use cases. So let's have a look. Built-in APIs, very good list. And external components, you can find many websites dedicated to like repos of these ones. For this example, I use js.coach, good one. Camera, again, install it using npm, then link it. And the code is pretty much React, right? We have this JS6 template syntax, and the rest is quite similar to what we have. Promises, promise resolved, we got image data. Super simple. Progressive apps. We are limited to use only browser APIs, right? Because it's regular JavaScript application, and we don't have this privilege to use Cordova plugins or any kind of plugins. But in general, it's not a big issue for many cases. This is the list of hardware APIs exposed by really interesting website, whatwebcando.today. So it shows you all APIs available in your current browser where you actually open this website. So for example, for our camera sample, we can go for get user media API. And the code will look as a native, true, simple JavaScript. But using some latest APIs like media devices in Navigator, the first line, and get user media. So basically, we bind some object to video stream, and then on a function like take picture, we could put these snapshots to our canvas. Quite simple. What can we give to our users using all these latest and greatest approaches? Of course, the main point is performance. Performance in a wide sense, like smooth scrolling and transitions, like fast and reliable network communication layer. Disclaimer first. Of course, the key component of performance is our own code, the quality of our code, right? So let's have an assumption that for all next points, we have the best possible code for each specific platform and use case. Then we can say that there is really no serious performance difference between truly native applications and the ones using JavaScript-to-native approach. After all of them are truly native. Unfortunately, hybrid version will never be as fast as native one. It's obvious. More abstraction layers, slower performance. But I have to mention that Ionic team does a really great job on optimizing everything that's ever possible to optimize in this sense. For example, they have a special plugin that can replace the older version of WebView called UI WebView to a newer one called WK WebView. It's not default yet because they didn't implement some features yet, but you can go for it today. Just test your application. As a result, application faster, less memory pressure, better FPS rate. Let's advocate a bit more for a hybrid approach. Once you got the performance which is fast enough for your users, for your specific use case, maybe you can stop at this point. What do I want to say by this? Of course, the faster, the better, but there are really many types of mobile web applications that can be implemented using Ionic and provide good user experience in terms of performance, including many kinds of business applications, like form-based applications, whatever. All applications that don't really need this 60 frames per second, don't need heavy work with graphics and so on. Also, Ionic applications are super suitable for really fast prototyping. Plus, browser vendors, they constantly work on improving their performance. What was stated on at this Google I/O that Chrome for Android, thanks to some optimizations, become seriously faster just during the last year. Our last chapter, some thoughts on more or less business-related things. Bad news for a native approach here. Almost half of the consumers go to search for application they need to search engine instead of App Store. So NativeScript and React Native, they really don't have anything to offer to those people. Ionic goes smart way. If you remember, I emphasized this one single code for all platforms. So using Ionic approach, you can create both web application and the one to be compiled to, say, almost native one. And Ionic team constantly contributes in this web direction. For example, recently they introduced some optimized layouts for your desktop apps, plus they have experience with progressive apps, so to combine all these approaches. We can continue with some bad numbers for app stores, which means for native approach. These app stores full of never used applications, especially Google Play. It's just a really ridiculous number. And downloads, they go slower and slower each month. And it means on this slide, less than 3. It's not a heart emoji here. If these downloads go at all. So numbers are quite frustrating. And the bottom line, it's really expensive to get new users for native mobile applications. Progressive web apps definitely win in this area. First, easy to find. Basically, this is a web application. Type your keyword, and the app is there. Really interesting that Microsoft, they go even further, at least plan to go even further here. They will scan the web using their Bing spider, and they will search for some good progressive web apps following some criteria and put them automatically to their Windows store. So just imagine, as a developer of progressive web app, one day you wake up and see your application in Windows store without any actions from your side. Of course, you can prohibit it via robots.txt, but the plan is following. Easy to share. Send a link to application or even specific part of application, in sometimes specific state of application, and you are there. So it's more or less impossible to do it for real applications, right? Easy to install. It's even hard to say that we have to perform any actions to install the progressive web app except giving the permission, because using some APIs, as a developer, you can you can pop up this dialog. Hey, dear user, if you wish to install this app for later usage. And you remember that I mentioned that progressive web app is a living standard. Some time before, this dialog could be shown only after some conditions were performed, some conditions that are hard to control for us developers, like, of course, this app should have service worker, this app should have app manifest, which is simple JSON file with some meta information about app, like icon, like name, plus user, they have to visit our application at least 2 times with break in between these visits, like 15 minutes or so. So really strange requirement, just to kind of confirm that user is more or less interested in having your app installed. It was in past. Now we, as developers, have full control on when to show this dialog. Again, great possibilities mean great responsibilities. Most likely, you will not want to show this dialog immediately, because just imagine user opens some app and bam, dialog. User even haven't started to work with this app. In most cases, they will just reject it. So be smart as a developer. So find a proper way to offer this installation to your user, maybe after some successful action that user performed in your app. And by the way, mobile app developers, they are good in finding the proper moment. So if you remember some mobile app experience, most of apps, they show you the dialog with request to give some rate to this app, not immediately, but after some time, after you did something interesting and meaningful and successful. So follow the same idea here. And easy to update. Basically, to expose the new version, all you need is just to deploy your app. No need to go for App Store, wait for this approval, and maybe you will be rejected. And yeah, it takes some time. Plus, even when you have a new version of your app in App Store, anyway, it will be not immediately downloaded by mobile device. So again, great possibilities, great responsibilities. It's quite easy to implement service worker this way that your user will never get any newer version of your app. So be very careful with this. Back to our question. We need mobile app. Now you have something to say, right? You have some options. I hope you have some opinions. So let's go to create nice mobile apps using one of presented ways or some other ways. But please remember that first action in a day for half of smartphone users, which is basically more than 1 billion people, is to grab their smartphone. So please, do not confuse and do not make this people say, do not ruin their early morning experience by offering not so good user experience in your mobile apps. So let's create great ones. Thank you very much.